Good morning all. My name is Arvind, as introduced. Okay, so from past 3 to 4 days, you have been experienced with different types of sensors or actuators, or the theory of sensors. What are the working principles of sensors? So I don't bore with most of the theory part. I'll show the application of sensors in automotive sector, like you would have experienced about engines or vehicles. Most of the people would be driving the vehicles, but most of us don't know there are some sensors. Most of us, some people would have known it, but most of us don't know what are all the sensors we are using in automobiles, two-wheelers or three-wheelers or whatever it is, four-wheelers, whichever. So as Bosch, we have a different variety of sensors. Can take powertrain exhaust sensors as one type, and then we have chassis control sensors. We have hydraulic sensors, different sensors. You have seen power tools. There are also some sensors which are used in power tools. There are some sensors being used in the home appliances. You would have seen Bosch fridges, Bosch washing machine. Not only Bosch, all other appliances also will use it, but as an example I am quoting that. Okay. So now we will see what are all the types of powertrain sensors and exhaust sensors which we use in our engines or vehicles. So you would have experienced this anyway. No need to explain what is a sensor and what are all the examples of sensors. So this is how the sensor schematic looks like. A simple schematic, like you would have seen in 3 Idiots. There will be a big definition for a sensor, but Asani Bhasha mein, what is a sensor? You have to understand, that's all. So there is the small definition and some examples of the sensors. A thermometer can be a sensor. A thermocouple, yes, as you people told, it's a sensor. So we'll go through the topics, portfolio of Bosch, and what are all the powertrain sensors and what are all the exhaust sensors, where it is applicated on the vehicle or the engine. So this is a typical engine layout, a diesel engine layout for a commercial vehicle. So maybe somebody would have known this, somebody wouldn't, but just for an example, I am quoting this reference basically. So the rounded ones in red, they are all the sensors which are being used in a system or a vehicle layout. This is for a diesel engine, and this is a gasoline engine. I am not rounded here. Most of the things in yellow, you can see these are all the sensors. Okay, different types of sensors. Maybe we'll see what are all the uses of this sensors, where it is applicated on the vehicle. So most of the sensors work on the principle of electronics, as all you know, the same principles which you would have seen in the last 3 to 4 days, like piezo ceramic or pressure transducers or something like all these which we would have studied somewhere in our engineering. At least you people are studying, some people are teaching. So for me it's around 12 to 15 years back I have studied, and now I am experiencing this in my day-to-day activities. That's what is the difference. So these are all the types of sensors being used in different types of vehicle segments. You can see two-wheelers or heavy duty, off-highway cars, everything. So these are all the sensors which we use in these applications. So we have powertrain sensors on the right side mostly, and exhaust sensors on the left side. These 4 sensors are exhaust sensors, all others are powertrain sensors. Yeah, powertrain sensors, types of powertrain sensors what Bosch deals with basically, or almost all the companies, automotive companies like automotive suppliers deals with, like pressure sensors, air mass sensors, position sensors or speed detection sensors, then knock sensors and temperature sensors. These comes under powertrain sector. So, a low pressure sensor, where it is applicated means measures the intake manifold air pressure and temperature and measures boost pressure temperature. Most of the people you would have known about these terminologies, but or doesn't know. These sensors gives the feedback to the ECU for the functioning of the vehicle. That means sensor is a feedback device, means it gives feedback to ECU for further control from the ECU. Okay. So, mounting location, I do not know how many people of you are from mechanical, how many people are you from electrical. Some people would have known about engines, vehicle layouts, all these things. So, you people can easily understand what I am talking about, intake manifold or after turbocharger or whatever it is. So, the thing is, it is a small sensor, what we call it as, and it has standard design. You can see the features, and we have different types of sensors like absolute sensor, differential sensor and relative pressure sensors, and the range is 0 to 4 bar, that is nothing but 400 kPa, and temperature range, operating temperature range for all sensors it would be normally -40 to 130 degrees centigrade and optional of 150 degrees centigrade with different types of coating. It is for 130 degrees centigrade the terminals would be tin plated, and for 150 degrees centigrade the terminals will be gold plated because of the thermal conductivity of gold. Okay. So, these slides may bore you a bit, but functional principle wise, we use a Wheatstone bridge concept here for the pressure measurement. Most of you people would have known Wheatstone bridge from your studies. I will just show you how this one. See, in this, okay, anyway, this one is there. So, this is a Wheatstone bridge what we would have studied, but how it is applicated here in automotive sector is like, see, a pressure sensor basically detects the pressure in terms of some voltage. It gives in terms of voltage to the ECU. What happens is, here you see like we have two chambers in automotive sector I am talking about. So, we use pressure transducers here. Okay. This is one zone and this is one zone. So, for an absolute, what I am talking about, absolute, differential and relative pressure sensor. So, one zone, the down zone or the lower zone will be placed in or fabricated in vacuum, means it does not have any effect because of some pressure. What is a pressure transducer here? What we are using is, when you apply some pressure, the resistance changes. Here what we are using. Okay. So, in vacuum there will be no any of the influence of pressure waves or something. So, it is an absolute 0, that is the reference here, and this one will be placed for the pressure measurement of the intake manifold or the boost pressure, the area of application. So, when an incoming air pressure is available and that touches this area, this fabricated area which is exposed to that zone. Okay. So, because of that incoming air pressure, there will be a change in resistance. So, when there is no any disturbance or the pressure, incoming pressure, there will be some voltage which will be given to the ECU, that you can see here is 0.4 volts. It will be constant at without any pressure, that is atmospheric pressure. This voltage will be around 0.4 volts, and based on your incoming pressure the value changes, the resistance value, and this is implicated like you can see the formula, the transfer function, and then this is linear again to up to 5 volts. So, you can take at 0 pressure, that is relative pressure, this would be 0.4 volts, and we have seen that the maximum pressure what is 400 kPa, at that 4 bar pressure the voltage would be 4.65 bar. So, that is how it is. The feedback is given to ECU. So, this is one type of pressure sensor. So, this is the small design how a Bosch sensor looks like. Then differential pressure sensor. The same principle is applied here, but the thing is there the Wheatstone bridge is placed, one reference is placed at absolute vacuum, but here we are giving two difference pressure zones. Okay, the difference in the pressures is calculated from this sensor. Where it is being used is across DPF and EGR. It is nothing but diesel particulate filter in the layout, and EGR, exhaust gas recirculation unit. Okay, and it measures the pressure and temperature. Okay, anyway, all the pressure sensor are integrated with a temperature sensor also. It works on the principle of NTC, that will come into later in next slides. So, pressure and temperature across the EGR. So, there will be some pressure drop if your particulate filter or something is clogged. So, to detect that clogging or the down in the pressure or lower in the pressure, this sensor is used. So, at a particular point where the pressure is very high, the difference is very high, you will be going to change the unit. So, that is how, that is feedback which is given to the ECU that there is some problem in this area. So, you have to do the calibration or you have to change the unit or something like that. That is again a feedback. So, this is how the design of the sensor looks like. Most of you people would have many doubts. If at all you have any doubts, you can stop me right away and you can ask, because this maybe for you people in academics, these subjects wouldn't have been dealt. So, the same thing for me also. Yeah.
How you are maintaining that absolute vacuum in earlier case?
Yeah. So, the thing is this is called a pre-mold and it is the heart of the sensor. Okay. In this there is a small again circuitry. In that circuitry this fabrication is done, and there means it is very small minute one, in that there are very means many layers, and we use small very small resistors or whatever it is, pressure transducers, and these are all fabricated, and in that pre-mold you have different layers. Okay. So, in that different layers, one is again a vacuum chamber, small chamber. If I go to details, there I can for only one sensor I can take some. Yeah.
I want to know how you are maintaining the vacuum level in that chamber.
Yeah.
All lines, because leakage will be there. So
That's a completely closed one. In the process, it is taken care. Yeah, it's completely sealed.
so complete, but what is the leakage of those sealing?
Absolute,
How much here?
absolute, zero.
It
That's
cannot be zero. So what is the leakage rate? It has to be. It has practically leakage.
In this electronics world, everything can be made. See, theoretically and practically, yes, when we study about theory, we always talk about ideal things. In practical ways, yes, there are some differences, means we cannot achieve this theoretical value. But yes, due to this microelectronics, you can achieve these things also. Yeah. This again, if I take, we have a fabrication, this one procedure for this one with around 20 or 30 slides, which I can explain what are all the procedure, what are all the processes we are using to maintain this, all these things. Yeah. Yeah.
Are you putting any micro pump and all these things there?
Nothing. It's in the process. Yeah. So then, a high pressure sensor, we use the same principle is being used here also. We have absolute and also differential pressure sensor. Sorry, not differential, relative pressure sensor. For absolute we are talking about vacuum, for relative we are talking about the room the atmospheric pressure. The reference will be atmospheric pressure and your incoming pressure will be the output pressure. So, here we have this high pressure sensor is used in diesel applications, mainly in common rail applications, and then in the this is a new technology for the gasoline engines, that is petrol engine. This gasoline direct injection. Okay. So, we have the pressure ranges are like 1500 bar to 2700 bar. So, the rail is basically to achieve the emission levels, you have to spray the fuel in terms of fine foam. So, you are pressurizing the chamber and through the injectors you are spraying it. So, for that what is the pressure what we are maintaining in the rail, we will be coming to know with this sensor. So, we have a different same concept of Wheatstone bridge is also applicated here again. So, yeah, the same this one. Only the thing is there we use for a low pressure sensor we use silicon micro membranes. Here we use stainless steel membranes to adhere to that pressures. That's the difference, and the design is varied to the position of mounting or the location whatever. So, the typical wave this characteristic curve will be like this. Okay. So, the design, and there we have talked about a pre-mold. The same thing here you can see, this is a hybrid which consists of this fabrication of the Wheatstone bridge concept here. Yeah, all these things are for mounting again. So, next comes air mass sensor. This hot film air mass sensor, we will come to know why it is called as hot film air mass sensor in the principle. So, again measures the mass of the intake air. The pressure sensor gives the pressure of the intake air, through which we will calculate the amount of the air based on the throttle valve opening, all these things. That is a calculation again. Here this air mass sensor directly gives you what is the incoming air in terms of grams per second or kg per hour, whatever it is, the units we can program it, that is also. Then optionally we have a humidity and pressure measurement ports along with the temperature of the intake air. You can sense the humidity of the intake air, temperature, and again the pressure measurement can also be an option for this sensor. So, mounting location is after air filter in the air intake system. So, you if you have seen in the vehicle, in front of the vehicle you have one big filter or something like where the air is sucked. Okay. Right after that filter this sensor is mounted, where you need to know, means the ECU needs to know the amount of air which is coming inside the engine, so that the amount of fuel can be injected. This is for the combustion purpose again, to achieve emissions or the functioning everything. So, the intake air mass is again an important thing for your combustion process. Yeah. So, these are all features again do not want to touch so much. It is mainly interested for the customers who are using on their vehicles or on the engines. Yeah. So, this is how this looks like. This is a plug-in sensor on the air intake system. Maybe if you would have seen here, this is the one, air mass meter. So, there is a cylinder, again this plug-in is what we are discussing now. So, measuring principle, again we use the same Wheatstone bridge concept here, 2 zones, where we use, there we were using for the pressure sensors, we were using pressure transducers, but here we are using thermistors. Okay. So, whenever there is a heating phenomenon happens, the resistance changes. So, the same concept is taken here. If you can see, this is the plug-in and this is the bypass, air bypass unit actually, where the small amount of air goes, and there this air goes like this. So, this is the chip inside that one, and this is magnified. So, it is a very small one, you can see 2 mm by 2 mm area of exposure to the air, incoming air. So, what happens here is again this, there is a heating zone T1 and T2, the thing is you are heating this element, and there is an incoming air. Incoming air is again an ambient atmospheric temperature, it will be with atmospheric temperature. So, when you are heating, normally a small amount of air which goes through that bypass structure. Okay. So, that will be heated to attain the maximum temperature at this zone, and after passing that zone again this air cools down, because it is a very small amount of the air. The heating can also happen faster, the cooling can also happen faster. Okay. So, the ideal condition is this red one. So, the zone, when you are heating at this zone, it gradually increases and gradually decreases, this is the heating phenomenon. When air passes, the heating phenomenon will be like this, there will be a bit lag, and then again it attains that final temperature and it comes down. So, what we do is here 2 zones, we are taking 2 different temperatures, you can see the delta T is calculated, the amount of air passes, you have more amount of air, it takes more time to heat it. So, that is the concept. So, at this point of time, since you have a lag here, you have some time or temperature it takes, and same thing here, it comes down. So, there will be a difference at these 2 points. So, that delta T is calculated, means the difference in the temperatures at 2 zones, and then how much time it will take in terms of microseconds or milliseconds, how much time it takes to that delta T to be attained, that difference in temperature, that is calculated into frequency. You know 1 by T is equal to frequency. So, then that is given as a frequency signal, and this is already calibrated and is in the ECU. So, when you give frequency signal from your air mass sensor, it directly gives the at this frequency what is the mass airflow, incoming mass airflow, that is the output of this sensor. Okay. So, this sensor is restricted to the passenger car segment because of the limitation of this principle. So, again this is how the design looks like, this is the sensor chip which we have seen here. So, again there are electronics for the calculation of frequency or all this delta T, all calculations will happen here, and from this is given to the ECU. Okay. So, this is the basic structure. Then we have one more called as the pressure based airflow meter. So, where for HFM hot film, that is why we are heating the film, that is why it came as hot film. Okay. So, it is restricted to passenger car segments, as I was telling, that is only fabricated for that application. And we have one more sensor called for off highway application, that is off highway application or commercial vehicle applications, everything we use this one. Same amount of air is calculated here also, the same location is used for the mounting, but the thing is we use a different concept here. We use a differential pressure concept, which is used mainly in the aeroplane pressure measurement. The inside the cabin there will be normal pressure, and outside the airplane when it is flying there will be very negative pressure, and based on that how it is maintained, that is calculated in that aviation industry. The same concept is being taken here, and we are calculating the reference pressure and the differential pressure and the temperature of the incoming air. Through this we are doing the air mass calculation. We use Bernoulli equation for delta P, and then ideal gas equation, and then conservation of mass. So, m rho and this delta P is attained from these the variables what we are collecting here, and this is applicated in the electronics inside, and then the mass of the air is calculated with this principle. Okay. So, this colored one we are getting from the sensor. for calculating the mass. So, next comes knock sensor, which mainly is used in gasoline engines, okay. Senses the engine knocking or vibrations, okay, mounted on the engine block near the cylinders. Yeah. So, the technology is piezo ceramic ring. The earlier presentation, the piezoelectric concept which we were talking about, okay, the same concept is being used here. If you can see, we have a piezo ceramic element. This is the structure of the or the design of the knock sensor, okay. So, we have a reference mass, that is seismic mass, which does not have any influence over vibrations, okay, and we have a piezo ceramic element which is highly influenced by the vibrations. So, you have a vibration, it will give the voltage. So, for that you need a reference. So, this gives this 0, and what is the difference? This is the voltage which comes out of the knock sensor. So, what is knocking? It is an irregular or a premature combustion. It is a timing, when there is a timing delay or advance in timing for the injection of the fuel. There is a phenomenon, this irregular mixture of air fuel happens, and there will be some small vibrations which causes in the chamber, this is a combustion chamber. Because of that, if the vibrations are very heavy, it can damage the cylinder valves or the pistons. So, you have to control the vibrations by advancing your fuel injection or delaying the fuel injection based on the efficiency of the combustion, okay. So, to make it too efficient, so the same thing what I have told. So, these vibrations are given input to the ECU in terms of voltage again, and ECU will control again the timing, all these phenomena. So, that is how the knock sensor works, okay. So, this is the functional principle with a linear output again with frequency, like vibration again is measured in terms of frequency, acceleration or vibration, and then this is the voltage which is given to the ECU. So, piezo effect, when there is a vibration, there is a charge which is developed, which is given to the ECU for further processing. So, next one is water or oil temperature sensor, which is also called as coolant temperature, we call it as. We use mainly in water cooled or lubricant cooled type of engines, where you need to know the temperature of the water or the lubricant, because your engine will be continuously functioning and it uses the same amount of oil or fuel, oil in the sense lubricant, to cool the engine. So, at certain temperature, more than some 100 or 110 degrees centigrade, there will be a serious issues which will be faced by engine based on the type of the engine again, okay. So, this temperature sensor gives the feedback of the temperature in terms of electrical signal to the ECU, so that you can reduce your speed or introduce some more water to cool it based on the feedback, okay. Measures the engine or coolant water or oil temperature. Then on the engine block for the air cooled or the water cooled engines, yeah, it is on the engine block. So, the functional principle, it uses a NTC element, it is negative temperature coefficient. You would have heard of this principle also, yeah. The thing is, normally we would have seen a phenomenon called positive temperature coefficient. Normally when temperature increases, your resistance also increases, but this is a negative temperature coefficient. So, whenever your temperature increases, your resistance decreases. This is because to have a wide temperature range functioning and to have less losses, because at high temperature, high resistance, you have high tolerance. So, the value will also be the same, the output value with the same tolerance. So, when you have this one at at lesser voltages you have lesser tolerances or limitations. So, this principle works here. So, based on the this again is the characteristic curve, which is a standard characteristic curve for that particular NTC. So, this is calibrated in the ECU. So, whenever there is a resistance calculated at that temperature, means we are calculating the resistance, and that resistance is inputted in the ECU, and this to that resistance what is the temperature, the ECU will be detected, the ECU will detect the temperature. Okay. So, the typical structure or the design of the temperature sensor. So, this is the NTC which is mounted inside the engine block. Okay. So, any doubts can always raise your. So, when moving to position sensors, again a crankshaft sensor called as speed sensor. So, measures the speed of the crank wheel or the engine. You would have seen in the dashboard the speed of the engine on your this one cars or whatever it is vehicles. So, the speed of the engine is detected by this sensor, okay, on the crank wheel or the flywheel or the crank pulley. These are the mounting locations. So, these are all the features again. Yeah. So, the principle, it uses two-wire variable reluctance principle. It is nothing but it works on the Faraday's laws of electromagnetic induction again. So, you know there is a permanent magnet for which there are this magnetic field, okay, and there is a moving target wheel with you can see the small teeth and slot. Okay. So, whenever the teeth comes into contact with this magnetic flux, that is cuts the magnetic flux, there is a EMF which is generated, okay, and at tooth the flux cut or the EMF induced is higher, at slot because of the distance it is lower comparably. Okay. So, this is how the voltage versus the speed, basically the speed of the engine takes like this, and the typical output will be in terms of a sine wave. You can see here also the phenomenon. So, this is a typical with 60 minus 2 target wheel, means why we have 60 minus 2 target wheel is like you need to know one rotation, after one rotation how you will be knowing. So, there is one tooth missing here, so that you will be knowing there is one rotation which is completed. So, that is how the speed of the sensor is calculated, and again this is used for the synchronization of your speed of the vehicle with the cylinder position for your effective combustion. So, that we will see in the next sensors. Yeah. So, this is the typical sensor design. Okay. There is a permanent magnet here, and there is a coil, and this is the bus bar, this is pole body which enhances the magnetic flux lines towards the target wheel. Okay. These are all the child parts of the design. Yeah. So, this one you have seen that the output is in terms of analog voltage. Okay. So, this is an analog sensor. We have one more sensor which is a digital sensor. Okay. So, this also the function of this sensor is also similar to what we have seen in the analog sensor, the same mounting, the same application, but the thing is here the output will be in terms of your digital signal. Okay. So, it is based on the efficiency you require for your ECU to calculate and analyze. So, the thing is digital sensor always has the higher accuracy, higher better tolerances when compared to analog. So, yeah, again cost is a matter for customers. So, they will have to choose whether they wanted to be cost effective or with the analog sensor also till now all the vehicles are running with you would have known about this emission legislations which are going to be imposed in 2020, that is BS6, which is Bharat Stage 6. For those applications they need the accuracy for calculating the position of the cylinder to synchronize with the speed of the engine to inject the fuel quantity for the effective combustion. So, at that point of time these sensors are very what you can tell, you have to use these digital sensors. Analog sensors right now we are using from past 30-40 years, but digital sensors they are used in European market right now. Indian applications very minimal, but for BS6 and above they have to use the digital sensors. Yeah. So, it works on the principle of Hall effect. There is a Hall chip inside, okay, is a magnet, and we have a Hall chip here. Okay, same concept, but the thing is there we use a coil and this one magnet, and directly you are giving the analog voltage to the ECU, but here there is a Hall chip which converts this analog voltage to digital and it gives the to the ECU. So, you would have known about this Hall effect. Right now the previous discussion also there was some hints about this Hall effect. So, the thing is there is a current carrying conductor where a perpendicular magnetic field is applied and there is a force called Lorentz force which is developed. So, because of this force, what happens is the charge which is flowing will accumulate at one end of the, because of that force at one end of the conductor. So, there is a potential difference which is created. So, that potential difference is given to the Hall chip. So, nothing like you have a Hall chip has a comparator, and that comparator will give if the voltage is you assume 0.5 volts or greater, it gives a 1 digital signal 1, and if it is less than 0.5 it gives 0. So, that is how it is what the output is calculated here for this one. So, you can see this is the typical output, and this is the signal which we acquire before the calculations from the Hall chip. So, this is how it is. There is the sensor and there are Hall sensors. Yeah. So, the advantage of this sensor is like you can detect the forward direction and also the reverse direction with the number of Hall sensors. So, that is again one more advantage when compared to the analog sensor. Analog sensor can also detect, but only one point of time it can detect only one, but here it can detect both if the phenomenon happens. Okay. This is the typical design what you can see. These are all the D23, 23i, these are all the types of sensors, position sensors or the speed sensors. Then we have one more sensor called speed sensor for the turbocharger. So, you would have seen to increase the power of the engine, some of the manufacturers are using turbochargers. Okay. So, to detect the speed of the turbocharger, this sensor is used. Normally turbocharger rotate at a speed of around maximum cap, you can see 400,000 RPM. So, to detect that speed this sensor is used. Again the same speed of this turbocharger is the application, and mounting location is on the turbocharger. It also works on the principle of electromagnetic induction. It gives the signal in terms of sine voltage, electromagnetic induction, Faraday's law. Okay. So, this is how the turbocharger wheel rotates, and this is the position, and you have a coil, you have a magnet, and this gives the input to the this one ECU. This is how the schematic, which this is how the basic design looks like. There is a small circuitry inside, it gives the output voltage through the connector or the terminals to ECU. We have one more thing called as position sensor, cam position sensor. Determine the position of the camshaft to know the location of the pistons in the cylinders for your that's what I was telling you, right? When you have to inject your this one fuel and air mixture or whatever it is, you have to synchronize your speed of the engine and the position of the camshaft or the piston. You would be injecting it at the top dead center TDC, and you have to compress it and then you have to ignite. So that for that process this sensor is used for the synchronization purpose to know the position of the cylinder. So for a 4-cylinder engine you have a different types or the profile of the cam lobe, for which you use one sensor, you know different because of that shape and size of the cam lobe, and for different cylinders you know the position of the cylinder, and for that phenomenon it is used. The mounting location, rear end of the camshaft. Yeah. So again it works on the principle of Hall effect, which we have discussed earlier, and it also has this one. So this is the typical target wheel, cam wheel for a 4-cylinder engine. So you have a different profile, so that you have to differentiate the cylinders. That's why this profile will change. Okay, and you have a digital output. So it works on the principle of Hall effect. Yeah. So typical design, this is how the ASIC. This consists of Hall, this one, and then magnet, and then a holder to keep all these things, then a cup to put this, then assembly, then the final sensor. This is how it looks. Okay, then we have throttle position sensor, which widely is used in gasoline applications, mainly in two-wheelers. So what this sensor does, determines the position of the throttle valve. Okay, so it is mounted on the throttle body. For an example, you have you ride a bike and you are accelerating your bike through that accelerator, means you are opening the throttle valve through a wire connected for the amount of air to be taken in. You are open, see at idle condition, at zero condition, when you have stopped the engine, the throttle valve will be completely closed, means there is no any intake air coming on the bike. So to raise the power, you are opening the throttle valve, so more air is sucked and more fuel accordingly, air fuel ratio, you know it. So accordingly to the incoming air, you are injecting the fuel and the combustion happens. So for detecting the position of the throttle valve, this sensor is used. So it works on the principle of potentiometer. Potentiometer principle is used. So there is a constant current which is supplied, and there is a resistance track. By opening your this one, you can see here, there is the potentiometer track where you can see. So the wiper rubs the potentiometer track. At this position there is a constant current flowing, and you know V is equal to IR, that Ohm's law. So from that V is calculated and is given to the ECU. So it is just to determine the position of the throttle. Yes. For gasoline engines, what we do is we do air control. For diesel engines we use fuel control. That is how it is calibrated. So that is about powertrain sensors. We move on quickly to exhaust sensors. I think we have another 10 minutes. We'll try to close it before. So we have different types of exhaust sensors which are used on the vehicle. One is oxygen sensor, then nitrogen oxide sensors, particulate matter sensors, and temperature sensors. Okay. So we have different types of oxygen sensor is nothing but lambda sensor, what we call it as. So people, you would have known lambda is equal to 1 at which the gasoline engine operates, means the stoichiometric ratio, those calculations are there which you would have known, or it is a new thing. To tell this is the complex sensor which the powertrain or the sensor portfolio with any of the customer they are using. This is the very complex sensor. It has so many this one sensing principle inside, then a chamber, all these things. It's a bit of complex in nature. So it measures the content of the O2 in the exhaust gas. So how you know that you have a proper combustion or efficient combustion? When your oxygen content in your exhaust gas is very less. You cannot avoid it again. It cannot be zero. You after efficient combustion also you will have some amount of oxygen. For that combustion, where the air is taken from the ambient through the air filter, this thing we have talked in the powertrain. Okay. So for the combustion, what happens? 20% of oxygen is 20 to 21% of oxygen is in the air, and the remaining 79% is something nitrogen, and a very few amount of 0.5% carbon dioxide, all other methane or whatever it is. So that oxygen is taken for the combustion. So before and after combustion, if the oxygen amount remains same, the 20 means there is no combustion at all, which doesn't take place. So for combustion you need oxygen, means to create a flame and to have a mixture and to do the combustion, you need oxygen. Okay. So the proper combustion gives it utilizes the more amount of oxygen, and it tells that you have done a proper combustion, that's all. Okay. So with the amount of oxygen in the exhaust gas, you can come to know the combustion level, and where this oxygen sensor is mounted is on the exhaust tail pipe. Maybe you would have seen the this one, what silencer, sorry, silencer. Before the silencer, before the pre-cat or catalyzers, all these things, it is located on that one. That's what some like 4-wheelers and all will have catalysts to monitor the oxygen content. So pre and post, before and after, they use oxygen sensors to detect the oxygen level in the exhaust gas. So uses a Nernst cell, Nernst principle. Maybe some of you would have heard of, because when I was in engineering, at least I have not heard of this Nernst principle. So yeah. So the thing is, this is how if I can show you. So this is the typical oxygen sensor. It looks like. Okay. It has all the this one like wires, this grommet and this hexagon, and there is a separator with packing, and this is the sensing element. Okay. So this is responsible for giving out the oxygen content in terms of voltage or current signal. Okay. So the thing is that you remember this one. So this is the cross section of that sensing element. That sensing element, you can say it will be around 0.5 to 1 mm thickness, and it has again several layers, around 10 to 12 layers inside that. Means the fabrication, the sensing element again is manufactured in Bosch, Germany. It has at least 100 process steps. For one small, this will be like this one in length, and the thickness will be around 0.5 mm, what I was talking about. It has 100 process steps, in which you have electrodes, you have a heater, you have a reference chamber, all these things. How this is calculated, like it again it is a electrochemical principle what we use here. The thing is you can see this yellow one is a ceramic. It is a type of ceramic which sensing element is made of. It is a zirconium dioxide which is doped with yttrium. Okay. These are all elements of our chemistry. Yeah. So zirconia as such, it is a very bad conductor, means it is an insulator. Okay. It does not do any conduction. Okay. So it is doped with yttrium, so that it becomes a semiconductor. Okay. At some temperature, where there is a heater, as I have shown, the heater, when you switch on the lambda sensor or oxygen sensor, it starts heating. Okay. So at some temperature of around 400 to 400 degrees, 450 degrees centigrade, what happens? The ionic conduction happens, since it is a semiconductor, the ionic conduction happens inside this zirconia doped with yttrium, and you have a reference chamber of air. You can see this white portion. So, the thing is your oxygen, reference air oxygen, that is ambient oxygen, comes through these wires and it will be given to this sensing element, and this part is mounted on the exhaust tailpipe, where there is an exhaust which is experienced by exhaust gas, which is experienced by this portion of the sensing element. So, what happens is, at this point of time, you would have known about this osmosis principle, like from high level to low level, the concentration, the flow happens. Same thing, after the combustion, the amount of oxygen is utilized, some amount of oxygen is utilized. Okay. So, the reference has that 20% or 21% of oxygen. The comparison, so there is a partial pressure which is created here because of the number of ions, that is 20% of oxygen, and here there is a partial pressure which is created because some oxygen amount will be left over after the combustion also. So, because of that, the flow of ions happen, oxygen ions, from one electrode to another electrode. This is calculated as a current signal and is given in terms of its voltage. This is the formula, this is called the Nernst cell. This is the principle, Nernst principle, by which the oxygen content is calculated. Okay. So, this we have two types of oxygen sensors. You can see here, switching type lambda sensor. This gives either your mixture, that exhaust gas mixture is rich or lean. Rich means rich in fuel, less in oxygen. Lean means more in oxygen, less in fuel. So, it just gives you, based on the amount of voltage or the current which is generated here because of the transfer of ions, it gives whether your mixture is rich or lean to the ECU. Then ECU starts the air mixture, the combustion, everything for efficiency, and again it starts its cycle. Okay. It is an improving process. Either you are changing some parameter, it goes into rich, then you get a feedback, you are changing some parameters, again because of that it may go to lean. So, it will be again in terms of sine wave, where it will be at that lambda is equal to 1 level. So, it will be oscillating at that level. So, that is how the oxygen is sensed here. So, this is switching type, it will just say either it is rich or lean. This is mainly used in gasoline engines, because gasoline engines run at lambda is equal to 1 phenomenon, that is a stoichiometric ratio. So, the phenomenon how it happens is how it happens at that 450 degree centigrade. So, from reference air electrode to this one, the ion starts moving because of the difference in the partial pressure. Okay. So, that is how this is because of the partial pressure. This is how the U Nernst is calculated, and this is the typical curve how it looks like. So, to tell all my oxygen sensor, nitrogen sensor, nitrogen oxide sensor, and particulate matter sensor, in design wise it is similar, only the sensing element will change. So, the design is carried over for all the sensors, other sensors also. So, wideband sensor is the same lambda sensor, where we have seen the phenomenon of transfer of ions. The same concept is used here also, where here the thing is it gives exact lambda value. Lambda is equal to 1.1, 1.01, 1.023 or something like. The exact value will be given by this sensor to the ECU. It makes the ECU's job simpler, that is all. Based on your this one, the ECU can efficiently calibrate or give the parameters or the inputs. So, how till this point the same switching type is valid, means that is a single chamber sensing element what we use there. Here we use a dual chamber sensor, where due to so much research it is known that lambda is equal to 1 is achieved at this 450 millivolts. So, there is a chamber inside the sensing element, which is maintained at this this one what voltage level 450 millivolts from the ECU. The this one you can see the apply you are applying the voltage, taking the current from the ECU. So, this is maintained. So, this is lambda is equal to 1 is maintained here. Okay. So, this is a reference. Now you know less than 450 millivolts will be rich mixture, greater than 450 millivolts will be lean mixture. So, you have a reference. So, based on the amount of voltage generated here, you can directly give the lambda value to the ECU. That is the only difference what we have with this one universal type lambda sensor. Okay. We have two different types of sensors here again these are all the generations, 4th generation and this is 5th generation. This is used for both gasoline and diesel applications, CNG, LPG. Okay. We use this one only for diesel is because the soot content, everything from the diesel engines are higher. So, we need a robust sensor. So, there is a special sensor which is designed for diesel. So, that is again a lambda sensor for diesel. Yeah. So, this is the function of a lambda sensor. And next one comes nitric oxide, nitrogen oxide or NOx we call it as. So, as a byproduct of exhaust, you have this nitric oxides also. With emissions coming into stringent, we have to reduce the hydrocarbon content and the carbon dioxide content emitting out of the this one carbon monoxide content from the exhaust, because the CO2 is not very harmful, CO is very harmful as you know. Okay. Same thing is hydrocarbons, they are harmful, and the main legislations are coming out because of these this one HC and CO to be reduced. For that there are different methods which are being followed by the OEMs to control this. So, to control this there is a phenomenon called selective catalytic reduction SCR mode, which is used, where you are dosing urea, that is NH3, to reduce the hydrocarbon and CO, means due to the electrical reactions happening in the exhaust side. You are reducing the means HC is converted to H2O and CO2, CO is converted to CO2 like that. Okay. To the legislation says like that, and as a byproduct of that SCR topic we have because ammonia is NH3 again. Okay. N again there will be reactions with N with O2, it becomes nitric oxide, nitrogen, N2O, NO2, NO, all these things are again harmful. So, you have to detect this, the level of NOx from the exhaust. So, that is why this NOx sensor is used. So, it measures the content of NOx and O2 in the exhaust gas again, and it is applied on exhaust tailpipe, and after the catalyst, means downstream we call it as in our automotive language, post the catalyst. Okay. Yeah, we will complete it. Yeah. So, this works on the principle, same principle here. You can see the chemical reactions. NO directly cannot be calculated. So, you have to first the exhaust gas goes inside due to the partial pressure. First with the same Nernst technology, the oxygen here is utilized, oxygen content. So, the oxygen is the first output which we get from this NOx sensor. Then the remaining amount of this one will be going into the diffusion barrier 2, that is one more chamber where this reaction happens. 2 NO is splitted into O2 and N2. N2 is again nitrogen harmless. So, you are calculating this O2 again here the amount of current that calculates the NO. That is how this is. So, this NOx is used both to know the oxygen content in the exhaust gas and also the NOx content. So, then we have a particulate matter sensor. So, particulate matter sensor is after the combustion what happens, there are some small particles which emits out of the combustion. When this combustion the byproduct of combustion, that small particles, when these particles come into contact with the ambient air, there some reactions will happen, and this particles will grow in size because of the humidity. So these are potential disaster, this one for our body. When we inhale, it goes into lungs and these things, and it can be harmful. So there is a sensor which detects this one, where the thing is, you can see the same design, only the sensing element is changed here. You have a sensing element where there are two electrodes, you can see interdigital electrodes. At that point of time, the resistance will be means it is an insulator, it does not have any conduction path. So carbon, as you know, is a conductor. It is placed in the exhaust gas, and this one it comes in contact when you are placing this in exhaust gas. Okay, this soot particles will come and sit on this this one or track on the sensing element, and there is a conductive path which is created. So based on the resistance of between these electrodes, what is the amount of soot is given to the ECU. This is one more last sensor, exhaust gas temperature sensor. We have talked about coolant and water temperature sensor in our powertrain sensors, but there is a need for this one exhaust layout also to know what is the temperature at which your combustion or the output of the exhaust is. So you have to control that also. Okay. So for that we use exhaust gas temperature sensor. We have different types of temperature sensors with -40 to 1150 sensor, sorry, degrees centigrade. It can sense till this. Again, it measures the amount of, sorry. Okay. It measures the temperature from the exhaust gas. So sorry for this one. Okay. Mounted on the exhaust tailpipe, outlet of EGR, same thing, exhaust gas recirculation, and then DPF, after the DPF and before DPF. So this is the typical assembly. So this is the sensing element where it is fabricated, and this works on the principle of PTC, positive temperature coefficient. Negative temperature coefficient sensors have some limitations to the operational range. Maximum we have seen is 250 degrees centigrade at which it can sense, but when we have to go for 1150 and all, we have a sensors only with the positive temperature coefficient sensor, where with the resistance increases when temperature increases, that is the output which is given to the ECU. Thank you. Yeah. So whenever you have an opportunity, you can visit Bosch. We can arrange for a demo. We can show you people how these sensors are applicated. Sorry for time constraint or something. We have actuators also, but we didn't cover these actuators. Yeah, yeah. So that's how it is. Because I have requested ma'am for 1.5 hours so that I can explain. Due to some this one we have a small. Yeah, I understand. Yeah. So. Yeah, thank you. And if any doubts or something, you can always reach me.
Yeah. Tata, they were saying that they are not able to get any sources, Italian company, or they are auto transmission type of things.
Okay.
So why you are not doing those kind of bits and all these things? Auto transmission, auto transmission.
We have it. Bosch chassis systems does all these things. We have 8 types of this one companies in Bosch. Bosch software, Bosch Automotive, Bosch chassis, Bosch hydraulics, Rexroth, like this. There is a different division. Packaging division is also there in Bosch.
India?
India, yes. In India I am talking about. In worldwide also it is there. In Pune it is located, this chassis systems, transmissions.
You were saying the monopoly of that company, Italian? Tata Motors, they were saying that for Italian company, they have.
There are many companies. Yes, monopolies again, it's different. Bosch is a monopoly in diesel systems. It is not a monopoly in transmission systems. It has its appearance in this areas also. We have in home appliances, as you know, we have everything, power tools, everything. So. anybody any doubts or something, you can always contact me, ma'am. You can, yeah. I'll yeah, K2 dot Arvind dot K2 at in.bosch.com.